So if a system is damped, okay, whoops, I'm going to get into a pen. If it's damped, if we look at this thing, this is, we started a system oscillating with a vibrator or something like that, right? Okay, there it goes, and at about 40 seconds, notice that it kind of levels off. Okay, so from here to here, it gains energy faster than it loses, right? Now it's gaining energy at the same rate. Presumably we're pumping energy into it all constantly throughout this whole thing, right? But it's not losing energy very fast because the amplitude is small. When the amplitude is small, the velocity is small, and the damping force is proportional to the velocity, right? So at low velocities and low amplitudes, it doesn't lose energy very fast. But at some amplitude, the velocity is such, the average velocity is such that it loses energy equal, it's the same as the rate at which it gains the energy. So for this part here, right? So this is equilibrium, right? I'm in the computer lab right now. It sounds like a set of Das Boot. All right. So this is, and let's look at another slide here, right? So this is the same concept, right? If I let this thing, I'm predicting a question like this on the test. Notice that this envelope kind of looks like an exponential decay. And that's because, of course, at first it's losing energy fast because the average velocity is fast, right? The force is minus kv. V is big, so the force is big, right? The k is a constant, right? As we go farther and farther along this, the velocity, the average velocity gets smaller and smaller, and so therefore the force gets smaller and smaller, and so it loses energy at a more gradual rate, okay? Yeah. And then as far as damping goes, this is over damped, right? So this is like you put a mass, if you put a mass in cold molasses, right? Eventually it will reach equilibrium, but it might take a long time, right? This is like a door closer that's set so it's annoyingly slow to close the door, right? C is underdamped, right? This is even more underdamped like that, right? And B is critically damped, and this is really important. This is the shortest time, right? When we talk about Q factors later on, Q is how many cycles it goes through before it stops. So this might be 1, 2, 3, 4, 5, 6, 7, 8, maybe 8. A Q factor of 8, right? The Q factor of B, Q is 0.5. That is, it goes through a half a cycle. That is, it starts at maximum and goes to rest, right? A half a cycle, this is half a cycle, right? Okay, so this is the shortest time. They always, right? They always want you to know that. They ask that, right? So critically damped returns the system to equilibrium in the shortest time possible.